Greetings from Taiwan. My name is Peter.Hanson, and I am a tomato breeder, vegetable breeder based at the World Vegetable Center here in Taiwan. And I'm presenting this study on behalf of my colleagues, Rui Yang, Ngoni, Tsvetelina, Stoilova, June Acedo, and Didit. The title of the study is Nutritional Quality of Traditional African Vegetables as Affected by Drying Methods. So traditional African vegetables are high quality nutrient sources and inexpensive, so very important in Africa. However, availability is highly seasonal and post-harvest losses can be very high, up to 40%. So drying can be a means to preserve these vegetables and improve their availability. But drying method can affect nutrient contents. So different drying methods have their advantages and disadvantages. Sun drying vegetables is common and it's inexpensive but weather dependent. Low-cost solar drying equipment is increasingly available in Africa. It speeds up the drying process, does not require electricity. Freeze drying is a low temperature drying process with less effects on the chemical properties of the compounds. And oven drying allows even temperature control. And it's a very common process in industrial food processing. So the objective of the study was to assess the nutrient contents of popular African leafy vegetables as affected by these four drying methods. So two related studies were conducted one at WorldVeg-Taiwan, study 1, and the other at WorldVeg-Tanzania, study 2. So in both locations, 2 varieties each of 5 traditional African vegetables were grown in field trials at Taiwan and Tanzania. In study 1, the samples were either freeze-dried or oven-dried. In study 2 in Tanzania, the samples were subjected to solar drying or direct sun drying. So the treatment design in both locations was a split plot with varieties as the main plot and drying method as the subplot factors. So main plots were arranged in a randomized complete block with 3 replications. 3 to 5 kilograms were harvested from each subplot and subjected to the different drying methods. And the World Veg Nutrition Group analyzed the samples from both studies for minerals, carotenoids, protein, vitamin C, and oxalates. These are photographs of the vegetables that were included in the study. So African nightshade, amaranth, cowpea leaves, jute mallow, and spider plant. And these are just some of the solar dryers that were used at Arusha of different models, cabinet types, chimney types. All are passive dryers that, again, speed up the drying process. Results, we found that all 5 traditional African vegetables were high in protein, minerals, carotenoids, and vitamin C, so confirming their nutritional value. Under study 1, looking at freeze drying and oven drying in Taiwan, mineral content, so iron, zinc, and calcium, were similar for either freeze drying or oven drying, while protein content was higher under freeze drying versus oven drying. Vitamin C levels under freeze drying were 11 times higher than oven drying. In study 2, comparing sun drying and solar drying in Tanzania, mineral and protein levels were similar either for sun drying or solar drying. However, vitamin C was not detectable in samples after either sun drying or solar drying. So in conclusion, minerals and protein are heat stable. Contents were preserved across the drying methods. Vitamin C is lost after either sun drying or solar drying and best preserved by freeze drying. Beta-carotene and other carotenoids are also reduced by sun or solar drying and best preserved by oven drying. Oxalates, an anti-nutrient, were notably high in amaranth across locations and drying methods. And solar drying, sun drying had similar effects on the nutritional quality of traditional vegetables. So we're very grateful to the United States Agency for International Development that funded this particular study, and to the other long-term strategic donors to the World Vegetable Center. So thank you very much.